All right, everyone, this will be section 10.4, which is on the hyperbola. So we have three objectives. Objective 1, we want to analyze hyperbolas with center at the origin, find the asymptotes of a hyperbola, and analyze hyperbolas with center at h, comma, k. So our definition of a hyperbola is that a hyperbola is a collection of all points in a plane. The difference of whose distances from two fixed points called the foci is a constant. So a similar definition to what we had to our ellipse, but quite different here. We say that the line containing the foci is going to be the transverse axis. So before we call it the major axis, it's now the transverse axis. The midpoint of the line segment joining the foci is the center of the hyperbola. The line through the center and perpendicular to the transverse axis is the conjugate axis, which we before called with ellipses, we called the minor axis. The hyperbola consists of two separate curves called branches that are symmetric with respect to the transverse axis, conjugate axis, and the center. So before we saw our ellipse was in a kind of an oval shape, we still have the same concepts here of vertices and foci and center and different axes, but the difference here is that for hyperbolas, at our vertex we have these branches or two separate curves, and our foci are then defined outside of the vertices instead of inside like our ellipse was. The 2 points of intersection of the hyperbola and the transverse axis are the vertices V1 and V2 of the hyperbola. So, right on to objective 1. We want to analyze hyperbolas with center at the origin. So our theorem here with equation of a hyperbola center at 0, 0 with the transverse axis along the x-axis. An equation of the hyperbola with center at 0, 0, foci at negative c comma 0 and c comma 0, and vertices at negative a comma 0 and a comma 0 is going to be x squared over a squared minus y squared over b squared is equal to 1, where b squared is equal to c squared minus a squared, and the transverse axis is the x-axis. So the equations look very similar to the equations for an ellipses. The main difference that we see is that we are now subtracting that y term instead of adding the y term. And that's really going to be the main difference that we see. So if you ever see an equation with a subtraction symbol instead of an addition symbol, that's your hyperbola. If you see this equation with an addition symbol, remember that is going to be your ellipse. But other than that, everything is about the same. Then recall that analyze the equation means to find the center, transverse axis, vertices, and the foci of the hyperbola, and then we're going to graph it. So for our first problem, example 1, we want to analyze the equation x squared over 16 minus y squared over 4 is equal to 1. So we're going to write a little bit on the side here. We can say that from this, we get that a squared is equal to 16, b squared is equal to 4, so c squared, which remember was, or it is going to be a squared plus b squared in this case. So before we also had that c squared was equal to a squared minus b squared. So now instead we have flipped a squared and c squared. So now when we want to solve for c squared, we just have a squared plus b squared. So our Pythagorean theorem. So this gives us 16 plus 4, which is equal to 20. So let's put this down there. Which if we take our square root, this also means that c is going to be equal to the square root of 20, which is the same thing as saying 5 times 4, where the square root of 4 is 2, so c can be simplified to 2 times the square root of 5. Plus or minus, technically. Then we also get that a is equal to 4, and then b is equal to 2. So we've determined our values of a, b, and c. So the vertices are going to be a comma 0. So plus or minus a comma 0. So this means plus or minus 4 comma 0. And the foci are plus or minus c comma 0. So plus or minus 2 square root 5 comma 0. So we can just say that c is equal to 2 times square root of 5. All right, so we found our vertices and we found our foci. For our next problems that we're going to do in the rest of our section, we will have another way to calculate this so that we're not necessarily doing the step that we're about to do, but since we haven't gotten there yet, we do have to do this next step. So we want to locate these points above and below the foci. I'm going to write this over here. So to locate the points above and below the foci, we're going to let x equal plus or minus 2 times the square root of 5. And then we're going to plug this value into our equation. We're doing this because we want points in order to guide our graph. So we have to draw out these separate curves, we have to draw these branches, but when we draw these branches, we kind of need a guide. We need to know where to go. And so these points that we're about to find are going to tell us where to go. So we're plugging this into our equation. Remember, our equation is x squared over 16 minus y squared over 4 is equal to 1. Plugging in this value, we are going to get plus or minus 2 times the square root of 5 squared divided by 16 minus y squared over 4 is equal to 1. 2 times the square root of 5 squared is going to be 4 times 5, which is 20. So we have 20 divided by 16 minus y squared divided by 4 is equal to 1. Now I'm going to simplify this and solve for y squared. So to solve for y squared in this case, we want each value to have the denominator of 16. So we're going to have 20 over 16 minus 4y squared over 16 is equal to 16 over 16. Then we can go ahead and simplify this. We can subtract 20 over 16 from both sides. This gives us 4y squared over 16 is equal to negative 4 over 16. We can go ahead, multiply each side by 16. When we do that, we end up getting negative 4y squared is equal to negative 4. Divide each side by negative 4. And this ends up giving us that y squared is equal to 1. So y is equal to plus or minus 1. So we get it. So the points above the foci, above and below the foci, will be the values of the foci. So we're going to have 2 times the square root of 5, positive 1. Negative 2 times the square root of 5, positive 1. Then we have our negative 1, so we have 2 times the square root of 5, negative 1. And negative 2 times the square root of 5 times, comma negative 1. So these are our 4 points. You should end up with 4 points in this case because you have a plus or minus c for your vertices, or for your foci, and then you have your plus or minus value of y. So you end up with 4 different points. So quite a few points here that we had to find. Remember, this equation asks us to analyze. So we wanted to find the vertices and the foci. We also want to find the center and the transverse axis. All we've learned so far was center at 0, 0 and the transverse axis along the x-axis. So this is obviously going to be centered at 0, 0 and the transverse axis will be on the x-axis. So we can write that in here. All right, so we've now stated everything that we need to. We have all the points that we need. So let's go ahead and plot them. So plotting our center first. Our center is at 0, 0. Next, we can plot our foci. So our foci are going to be at 2 times the square root of 5, 0 and negative 2 times the square root of 5, 0. 2 times the square root of 5 is going to be about halfway between 4 and 5. So our foci will end up being about right here. So we're going to say this is F1, and then this is going to be F2. Then our vertices are at 4, 0 and negative 4, 0. Then we have our points above and below the foci. So the points we determined are going to be at the same x value and then add positive and negative 1. So above the value that we already have, right about here and right about here. Same thing here and here. So this is our negative 2 times the square root of 5, 1, and this is our negative 2 times the square root of 5, negative 1. This is our 2 times square root of 5, 1. And this is our 2 times the square root of 5, negative 1. So we have all the points that we wanted to draw. So now we just need to connect our points and estimate our branches. So connecting these points is going to look about that. So we just want to continue on our branch as much as possible. And there we have it. That would be our hyperbola. So, all right. Just as before with our ellipses, we found ellipses with our major axis being on the x and y axis. So the same thing with the hyperbola, we can also have our transverse axis be along the x-axis or the y-axis. So previously in our last problem, we saw this with transverse axis being along the x-axis. So here's our theorem for it being along the y-axis. So we have an equation of the hyperbola with center at 0, 0, foci at 0, negative c, and 0, c, and vertices at 0, negative a, and 0, a, is now going to be y squared divided by a squared minus x squared divided by b squared is equal to 1, where b squared is equal to c squared minus a squared. And the transverse axis is on the y-axis. So the main things to notice here is that we did not switch a and b. When we were working with our ellipses, we switched the values of a and b to indicate which axis is going to be, in that case, our major axis. In determining our transverse axis now, in this case, instead of switching a and b, we are now switching x and y. So now we've started with y squared instead of x squared. And we still have that subtraction symbol, which is always a giveaway that is a hyperbola. So just restating, comparing the equations of hyperbolas with transverse axes along the x-axis and along the y-axis, we see that along the y-axis, the x and y terms in equation 3 are switched, and the greater value a is the denominator of the y term. We also get along the y-axis, the foci lie on 0, -c and 0, c, where b squared is equal to c squared minus a squared. So we see those slight differences there between our other equation with our transverse axis along the x-axis and the differences with our ellipse equations. All right, so objective 2, find the asymptotes of a hyperbola. So asymptotes provide information about the end behavior of a graph of hyperbola. So we can graph asymptotes instead of graphing those additional points above and below a foci, and these will also serve as guides. So the asymptotes of a hyperbola with the transverse axis along the x-axis, we see the hyperbola x squared over a squared minus y squared over b squared is equal to 1, has the two oblique asymptotes, y is equal to b over a times x, and y is equal to negative b over a times x, where we see the image of this in the image to the right. Then we have the asymptotes of a hyperbola with the transverse axis along the y-axis. So then the hyperbola y squared over a squared minus x squared over b squared equals 1 also has the two oblique asymptotes, but now our asymptotes are labeled as y is equal to a over b times x and y is equal to negative a over b times x. So we have our different equations for asymptotes depending on where our transverse axis is located. So the asymptotes of a hyperbola are not part of the hyperbola themselves, but they serve as a guide for graphing. So they're not actually part of a hyperbola, but they just help us figure out where we're going to draw our branches and give us a guide of where they're going to go for the future. So now when we think about analyzing the equation in problems, we will also be solving for asymptotes in addition to what we're already solving for, which was the center, the transverse axis, the vertices, and the foci. So all right, example 2, we want to analyze the equation y squared minus 4 times x squared is equal to 4. So first thing we want to do is that we want to put this in proper form. If we want to put this in proper form, what we end up doing is dividing each term by 4, and this ends up giving us y squared over 4 minus x squared over 1 is equal to 1. So now we definitely know a few of our values, but first let's determine the center is still at 0, 0. And the transverse axis is along the y-axis in this case. We know it's along the y-axis because our y term starts first. Now we can identify our values of a and b and c. So we see a squared is equal to 4, b squared is equal to 1. So c squared is equal to a squared plus b squared, so c squared is equal to 4 plus 1, which gives us 5, which means that c is equal to the square root of 5. We also see that a is equal to 2 and b is equal to 1. Then we know our vertices are going to be at 0, comma, positive and negative values of a, which are going to be equal to 0, comma 2, and 0, comma negative 2. Then the foci are at 0, positive, negative c, which our values of c are going to be the square root of 5. So we see 0, comma, square root of 5, and 0, comma, negative square root of 5. So we found our vertices and our foci, and now it's time to solve for the asymptotes. So the asymptotes R at y is equal to plus or minus, and in this case, since we have our transverse axis along the y-axis, we're going to have positive or negative a over b times x. So plugging in our values for a over b, this is plus or minus 2 over 1 times x, which means it's going to be plus or minus 2x. So our asymptotes are at y is equal to 2x and y is equal to negative 2x. So those are going to be our asymptotes. Then if we want to have a rectangle, we want to form a rectangle containing the vertices and the intercepts. So that means that we want to consider the points 0, comma, positive or negative values of A and positive or negative values of B, comma, 0, which means that we're considering 0, comma, positive or negative 2 and positive or negative 1, comma, 0. So we want to write or form a rectangle that's going to contain these points. These points are all going to serve as the corners of the rectangle. Writing out the rectangle is just another way that we can have a guide. Drawing out the rectangle is not necessary, but it does help alongside with the asymptotes. So, all right, let's go ahead and highlight all the things that we already know. The things that we want is that the center is at 0, 0. The transverse axis is along the y-axis. The vertices are at 0, 2, and 0, negative 2. The foci are going to be at 0, square root of 5, and 0, negative square root of 5. And then we have that the asymptotes are at y is equal to 2x and y is equal to negative 2x. So let's start graphing a few things first. Let's graph our center at 0, 0. We can graph our vertices and our foci. So our vertices are going to be at 0, 2 and 0, negative 2. Our foci will be at the square root of 5, which is just slightly greater than 2, slightly less than negative 2. This will be F1, F2. This here will be V1, V2. And then we also know our x-intercepts. So we have negative 1, 0 and 1, 0. Now that we've plotted all of our points, the next thing that we want to do before we actually draw out our branches is that we want to draw our asymptotes. We know our asymptotes are going to be at 2x and negative 2x. Let's go ahead. We're going to draw in our asymptotes with this purple color. Or let's do light blue, sorry, indecisive. So we have our light blue here. And we want to draw lines of 2x and negative 2x. When drawing lines of 2x, remember this is just going to be rise over run. So our asymptotes will be looking something like this. Then for negative 2x, we want to do the same thing. So pretending that those are about even, we can go ahead and we can try and draw out our branches now. We can also try and draw out this rectangle it talks about. So we see these are kind of the corners of our rectangles. And our rectangle is going to go through our vertices and our intercepts. So it just serves as another type of guide. The asymptotes are the most important parts. The rectangle isn't necessarily needed. But so we have our asymptotes, which are going to guide our branches. We have our vertices, so we can go ahead and draw them. So drawing our vertices out like this. We know our branch can't touch the asymptote, but it will approach it infinitely. And there we have it. We have our hyperbola graphed here with asymptotes.